So, spinning a raw and a boiled egg, you might notice that one spins faster, and that's one way to distinguish which one is the raw, which one is the boiled. And you probably have seen this, and you know that the one that spins faster is the boiled one. And if you touch them, what's interesting is that the boiled egg stops, but the one that's raw does not stop, continues spinning. So here's what's happening here. So this is a good demo for angular momentum conservation and also moment of inertia. So when you give the egg a spin, okay, you're giving it a torque. That torque is giving it angular momentum, and the angular momentum of the egg depends on the moment of inertia of the egg, which depends on how the mass is distributed within the volume, and that would give it certain angular velocity. So if the moment of inertia is greater, then you're going to have a smaller angular velocity. And this is exactly what you see here. So the raw egg has much larger moment of inertia or rotational inertia. Okay, why is that? So a boiled egg is very similar to a solid sphere. So the moment of inertia of a solid sphere, it's about 2/5 the mass times the radius squared. While the raw egg is gonna be more similar to what's happening in rotating a shell of mass that's empty. So moment of inertia of a shell, as you can see, is larger because the mass is located at the exterior, at the furthest away from the center of the sphere. Okay, so when you spin a raw egg, since the interior is fluid, you have a lot of viscous drag inside. Okay, and you have centrifugal forces, basically kind of pushing the contents to the edges of the shell, creating more of a distribution like this. Of course, you still have the egg filled in, but a raw egg would have a much larger moment of inertia than a boiled egg. Okay, and that's why it spins slower. Okay, another thing that you also see here with the stopping them, if you touch them, how the raw egg keeps spinning, that's because for the brief moment I actually stopped both shells. This egg retained angular momentum of its interior contents, right? So if I had applied torque, so in the non-inertial rotating frame of the egg, when I'm stopping it, I'm actually applying torque in the opposite direction in which it's spinning, so I'm trying to change its angular momentum. And the longer I apply that stopping torque in this case, like the larger the change in angular momentum the egg is going to experience, and I might actually bring it to a stop, right, if I hold it long enough. What I'm doing is I'm actually touching it very briefly, therefore the insides still keep churning inside, and there's some angular momentum that needs to be conserved. The moment I let go, that conservation of angular momentum keeps the whole shell spinning again.